All right, discrete mathematics. So we've been learning about something called propositional logic, and section 1.4 is going to introduce a sort of higher order of logic, a more sophisticated type of logic called predicate logic. So let's look at the statement 2 plus x equals 7. This is an example I gave of something which is not a valid proposition. Now the reason this is not valid is because its truth value is not clear. It depends on the value of x, right? Like if x equals 5, this is true. If x equals something else, this could be false. So this is not a proposition, but it is something called a predicate. That's predicate like that. A predicate is essentially like a statement like this that depends on the value of a variable. And if you were to specify the value of that variable, then it would become a proposition, which could be considered true or false. So another way to turn this a predicate into a proposition is to quantify that variable. This requires something called a quantifier. Let's look at some examples of quantifiers. So we could finish up this statement, 2 plus x equals 7, by saying 4x equals 5. So that would be specifying the value of the variable. We could say 4x equals 2, okay? Another way to quantify is by sort of capturing a bunch of different x's or stating that some x must exist. So one way we could finish up the statement is to say 2 plus x equals 7 for some real number x. So that's like claiming that some solution to this equation exists, but not specifying what it is. That would still make it a valid proposition. We could change, so here I'm saying some real number x. That is called the domain. Here we're saying the domain that x is coming from is the set of real numbers. That could be different. So I could say for some integer x, and hypothetically changing the domain could change its truth value. So in this case, it is an integer that is going to make this true. So in this case, it's going to be true in both instances. But you know, if you had an equation whose solution was an irrational number, then when you say for some real number, it would be true. But when you say for some integer, it would be false. So that can affect the truth value. And then another way we could finish this up is to say for any integer x. And changing it from for some to for any changes the claim that you're making. So when you say for some, you're saying like there exists at least one real number that is going to make this true. And when you say for any, it's saying like no matter which real number you put in, or no matter which integer you put in, rather, it's going to be true. That's a pretty like grand claim, right? To say that basically for any is the same as saying for all. So these are all different quantifiers, and depending on how you quantify the variable, you get a different truth value. So in this case, with x equals 5, we'd get true. With x equals 2, we'd get false. For some real number, yeah, that's true. 5 works. For some integer, yeah, that's true because 5 is an integer. But for any integer x, no, that's not true because there's lots of integers, like 2, for example, for which it's going to be false. So that's an example of quantifiers. All right, now before I go more into depth about what predicates and quantifiers are and the notation involved, I want to motivate the study of this subject a little bit by talking about the limitations of propositional logic. One subject that we are working towards in Chapter 1 is the idea of arguments and proof. How do you deduce statements from other statements? And so let's suppose that you are given that several statements are true. Let's say you're given all mammals in this room, the room I'm sitting in right now, all mammals in this room are human. Okay. Let's say you're also given Tristan is a mammal. I think I spelled mammal wrong the first time. Yeah, yep. Mammals. Let's say you're also given that Tristan is a mammal, yeah, and also that Tristan is in this room. All right, you'd think that we should be able to conclude that Tristan is a human, right? All mammals in this room are humans. Tristan is a mammal. Tristan is in this room. Therefore, Tristan must be a human, right? Well, the rules of propositional logic alone cannot conclude that Tristan is a human. In order to make that conclusion, we need to represent these statements with a different type of logic. We need to represent it with predicates and quantifiers. And then we have rules, logical rules that would allow us to make that conclusion we want to make. So this motivates the idea of predicate logic. I'll explain some details in the next video.